Hello, everyone. This is Rod Stellmuller, and this is another Tech Talk Tuesday. Today, we've got a really good show for you. We're going to be talking about cloud networking for on-prem network engineers, because our team here that's going to be talking today, Hamad, Saad, and Shazad are going, they spend a lot of time with customers, and we see a lot of times that network engineers that have built their careers on-prem are now trying to move into the cloud and understand some of the complexities of cloud. And these guys have had their own journeys in that area and really feel like it's a good time to help those engineers move their career forward. So with that, I'll turn it over to these guys and let you help everybody out here.
Absolutely. All right. So thanks everyone for joining. My name is Hamad. So I'm gonna actually, flip this the presentation. Usually, when we talk, the summary is at the end. I want to flip it on its head, and let's summarize the state of affairs today, right? Especially focusing on network engineers, and the people at least on this side of the table, we are this side of Zoom, are all network engineers, and we're hoping that the audience today and whoever is listening on streaming later is also tied to networking as part of what they do and how they define themselves, right? So what is the state of affairs when we go in public cloud? Like as organizations are moving to public cloud, the center of gravity of the infrastructure is moving into cloud. So what is the role of the network engineer in this whole paradigm? So if we start, right, when business is making the decision of going to the cloud, and that's actually interesting because it's not you and I or the infrastructure people who make that decision. The business is the one, the executive staff is the one that makes the decision that we need to transition or move to cloud. And the expectations, and I'm gonna kind of simplify it in a way which unfortunate, but it may resonate with a lot of you, is that the business thinks that the public cloud is gonna give me everything enterprise grade, faster, cheaper. And it would not just be limited to the applications, but it would include infrastructure. So the decades of worth of expertise that they have in the data center would just be available in the public cloud. Now, if you look at the teams who lead that transition to public cloud, is not, again, not the infrastructure people, not the networking and security people. And if you are in an organization where networking security is leading the first iteration of cloud, you are doing great. But for the most part, what we see is it's the DevOps team, the applications team who are leading the charge to go into the cloud because they are trying to, they want agility essentially, right? They want to do things faster, quicker, the time to market. They have a lot of pressure to deliver. And on-prem, the infrastructure is slow. It takes large organizations up to 6 months to get simple environments provision. So they're going to public cloud for agility. Now, when they go into public cloud, they start with consuming application. Their focus is consuming application, which is like the Kubernetes orchestration or Lambdas or databases or all these kind of things, right? That they can spin up in a matter of seconds and they can start building applications and delivering. A lot of time, starts with, let's go and explore, let's figure it out, let's see. And then slowly but surely that playground turns into an important infrastructure, and then it transitions into critical infrastructure. Now that's where the operations teams kind of come in, because they are now being asked to kind of support it, because DevOps turns around and say, well, supporting this thing is not my responsibility, it's someone else's job. My job is to build it. And then when operations teams comes in and tries to do that, it becomes a challenge for them, because they didn't define any infrastructure, they didn't define anything, and then they have no visibility there. Now, if you look at the end state of that, from if you are from the DevOps perspective, what the way they want to consume things is anything that they can automate, right? And they can kind of consume natively, that's good enough for the most part. For what that means is security group is good security, good enough security. And VPC peering is a great way of getting VPCs or VNets to talk to each other, right? That works great when you have one VPC, two VPCs, five VPCs. But as you start growing, as you start putting critical infrastructure, that becomes very, very complicated, and it does not scale at all. And it's not really their fault, because the DevOps teams, the applications team, have never built infrastructure. It's the network team who has always built the networking and security infrastructure. They are the one who define the architecture and then let applications team consume it. And that is an important piece missing in this cloud journey, that the applications teams have started consuming and defining things before an architecture has been defined. Now, oftentimes what I see is that the network engineers at enterprise that I talk to, they say that, well, we provisioned direct connect or express route or IPsec tunnels, and our job is done. Or I have Equinix or Megaport or this, and I've connected my on-prem to the cloud, and my job is done. Now it's up to the cloud team. And that's where today's conversation, we want to say is that, hey, that's just the first step. Your job is just starting, because when you go in the cloud, as these applications start growing, and then you have more business units, and then applications and environments like prod, dev, test, UAT, staging, across multiple applications coming up, and then not every application team is going to find the same cloud to solve or provide the applications that they need. For example, your teams may, the virtualization team is probably going to try to go to Azure and leverage the Active Directory and Exchange and Office 365. DevOps team is going to want to go to AWS, and ML AI is in GCP, and your Exadata and database people are going to try to go to Oracle, right? So everybody has a need which is satisfied better by a different cloud provider. So every time you add any bit of infrastructure to the cloud, the complexity is rising multifold, exponentially, when there is no architecture. And who defines the architecture is the networking team. So oftentimes what I'm seeing is that the organizations who started in the cloud 3, 4, 5 years ago, they went and they were like cloud 1.0, then they went to cloud 2.0, and now they're going to cloud 3.0, and this is where the networking team is trying to take charge, but it's a messy brownfield now. So my kind of call out to all of you is that the networking team has the most critical part to play in your organization's real estate in public cloud. So you got to take charge. You got to, be the front and center, the leading team who defines the infrastructure, and then use, for example, Aviatrix to let DevOps team build infrastructure at cloud speed. But they are not defining the infrastructure. They are deploying the infrastructure that you have defined, the architecture that you have defined. And in the next, half an hour or so, we're going to touch on some of these, pieces of architecture and infrastructure and challenges that you as network engineers should be aware of.
All right, so thanks, Abad. Thanks for summarizing everything. So let's talk about the first step. When business decides to migrate the applications, or developers who have already deployed the applications in the cloud, and now business wants to consume this thing from on-prem. So basically what you are looking for a bridge that is going to connect your on-prem environment to the cloud environment. So there are so many options available to connect your on-prem environment to the cloud. So top part of this diagram is your cloud environment, and I'm making it simplified over here. So that is not the focus of the tech talk. The focus is in this rectangle, this dotted rectangle, where we are going to build the on-prem connectivity. So as I mentioned, there are so many options available, and people usually get confused who are new to the cloud networking. So the first option, and now let's start talking about the pros and cons of all of those. So the first one is the private circuits. When you are connecting your on-prem, let's say the data center, to the cloud, you have an option to get the circuit, the private circuit, directly from the CSP. By the way, CSP stands for Cloud Services Provider. So your Google, your Azure, the AWS, all have different variants. For example, Google has the Cloud Interconnect. AWS has the Direct Connect. Azure has the Azure Express routes, right? All those are private circuits offering. By the way, not only the names are different, but the way they are being deployed and the functionality they provide are different as well. So just bear in mind, these are private circuits, so they are expensive. Another way you can get the private circuits is using the colos like Equinix and Megaports and PurePorts and all those other colos over there. The difference over here is these colo providers getting the thicker pipe directly from the CSPs. Let's say this is 100 gig of pipe, and then they are delivering it to their end customers. Maybe the end customer only requires a 2 gig or maybe 10 gig, but they are still getting the not exactly the dedicated circuit, because once they get to the colos, after that, this entire medium is going to be shared between a number of customers. The advantage of using these colos is if you are a multi-cloud customer, or maybe you have these private circuits in multiple regions, then you are actually getting a single port from these colo providers, which is very easy to manage. Okay, so again, this is going to be another expensive solution. What about some less expensive solution? Obviously, right away, the first thing in our mind is, how about if I can provide this connectivity using the internet? So definitely, that is also an option for you. So you can connect your cloud environment to the on-prem using the internet. But the question is, how are you going to secure it? You can secure it via IPsec, right? Okay, another variant is, I have already invested so much in the SD-WAN. How can I connect my SD-WAN world to the cloud world, right? So the architecture is, you can have their virtual devices. Most of the, or I would say the major SD-WAN vendors like Viptela, VeloCloud, Silver Peak, all have their virtual edges available in the different marketplaces. So all you have to do over here, you have to connect them via BGP with the Aviatrix Transit Gateway like that. The advantage of this approach is there is no tunneling protocol running over here, and you can use a traditional BGP connectivity between these two devices. All right, so this is the area which I'm going to zoom in the next couple of slides, because there is a lot of miscommunication or misunderstanding around this. So before that, let me talk to you about the IoT, like all those smart IoT devices which are running in the industries, the manufacturing plants, the oil rigs, and all those kind of different places. How are you going to provide the connectivity back to the cloud? Because they have to upload their data for the analytics. Most of these devices don't have any built-in mechanism to provide the connectivity, basically the IPsec. So they have to rely on some external devices. So all these areas where I'm just hovering my mouse, these are all hardware appliances. But you guys also have an option to use the virtual appliances like Aviatrix virtual gateways over here. So the advantage of this approach is you can manage them all through the single pane of glass and single control plane, which is the Aviatrix control plane, and then you will have the end-to-end visibility over here as well. All right, so let's talk about the SD-WAN. The architecture which I'm showing you right now, this is the best practice. You have SD-WAN, you already invested so much in there, you wanted to connect to the cloud world because some of the applications lives over there. If you have an architecture with multiple regions, you connect your SD-WAN world to the transit like the one I showed in the previous picture as well. And you can just repeat it in multiple regions and in multiple clouds like that. But sometimes the misunderstanding is that by the way, all these SD-WAN, devices, whether it's a virtual one or a physical device, all these devices are capable of providing the IPsec connectivity. Then why not I create an architecture something like this? So I can connect my virtual edges to the native cloud constructs like the VNGs or the VGWs and something like that, and then connect them together in different regions and different clouds. The question is not that whether it's going to work or not. The question is more around whether this is a good solution or not. So basically, this is a big no-no. Why? The reason is SD-WAN is not a cloud solution. It's a WAN solution connecting on-prem locations to each other, to data centers, to colos, and can also connect to cloud services provider. SD-WAN does not have ability to build and maintain the infrastructure in the cloud. They deliver traffic to the edge to the cloud, basically on-ramp only. And it's actually oblivious to anything beyond that. It's similar to that the SD-WAN is not a data center solution, right? So it's basically also not a cloud solution. At the same time, all these links which I'm showing you over here, that all these links within a region or between multiple region and multiple cloud, they have limited throughput. And Shahzad is going to discuss this thing in detail in the next few slides. Another important aspect of this is there is absolutely no operational model available in this kind of approach. So basically, this is your first step when you are moving into the cloud. All right, so over to Shahzad.
All right, thanks, Saad. I think that's very good because, as an engineer, when I started working in the cloud space with AWS, that was the first challenge I had. Like, okay, how do I actually connect my on-prem into the cloud? And there was no clear direction or information available. But I'm glad that we have a lot of information available, but there are still a lot of misconceptions, like you pointed out. The SD-WAN is a prime example. So let's talk about these cloud terminologies because, when you look from outside, the cloud looks like just a big box. It's a cloud, right? But that's not the reality because when you double click on it, then you actually see all the complexity. So the first thing you need to know is the concept of region, right? Because the regions are something which you need to have as part of your architecture in the cloud to provide high availability and disaster recovery and disaster avoidance, right? Because you have your application deployed in region 1, could be west, could be east, and then you have your application which could be in another region or could actually, in case of some failure, can actually spin up in the different application. So that is something what you will see as soon as you log into the AWS console. And I'm going to give you the AWS example because I started with AWS like many of you would have. So that's an important concept. You have to select the region in the console so that you are talking about the right infrastructure pieces there. And then the biggest piece here for the networking engineer is called VPC, Virtual Private Cloud. Now, when you log into AWS Cloud, there are hundreds of services, and majority of them are basically for the developers. So you have to really go down and then click on the VPC because this is going to be your life as a network and security engineer. So when you create the VPC, think of it as a pod because I came from the on-prem. I had this mental picture of the data center. How do I translate this picture into the cloud? So VPC became the pod for me, right? So at the pod level, at the VPC level, you specify the seeder, your top level seeder, like you can see on the screen is /16. It's a big range out there, right? And then within the VPC, you have a concept of AZs, availability zones. So if you want to map it back to the on-prem, that's your data center, right? Data center 1, data center number 2 within the same region. Let's say you are in US West in Oregon. You have 2 data center for high availability, right? So there is a regional level availability, and then also within the region, you have multiple physical data centers. Okay, so that's very important. It says cloud, but at the end, it has to run on something, on some physical infrastructure. So when you go one step deeper, beyond this availability zone, then you need to create your subnets. Okay, because at the end of the day, your applications, they need to run on a virtual machine. And the virtual machine would need the IP address from a subnet. So that's exactly what you carve out from your VPC seeder or the top level seeder that you created. And this is exactly where you're going to put your applications in. So if you go to the next level, you will see in Amazon, they call it AMIs or EC2 instances, or AMI for Amazon machine instance. At the end of the day, this is a virtual machine, okay? It's Linux, Windows, running your applications and providing you on the business the applications that they need. Now, you have all that. It's staying in the cloud, but it needs to talk to the external entities. Now, these applications are being deployed in the microservices fashion, right? The Kubernetes and whatnot. They need to talk to external services like the API gateway or the other SaaS services, or for your GitHub needs to go out and pull the new code, right? So that's the piece that you will see called Internet Gateway. And when I actually started working in the cloud, that was something really disturbing in a sense that your internet gateway is now sitting next to your application. In the on-prem world, we know we have the DMZ type services or solutions where you have a DMZ rack. It's caged, it's locked. Nobody has access to that because that's where the internet lives. But now it's sitting next to the applications. So you need to be very careful when you're creating your infrastructure in the cloud. You take care of all the security elements with it, right? So, and then you have the traffic going out. We call it egress here in the cloud world. The traffic coming in from the internet is ingress. So that's the definition that you need to remember. Now, another thing is the CI/CD pipelines. And when I started, it was not very clear, to be honest. But what you need to understand from the networking perspective, that this is the automated world. You need to make sure everything is done in the automated agile fashion. And for that, you need to connect to GitHub, GitLab. You need to have Terraform as part of your strategy. And that's basically the definition is for CI/CD. I know I'm making it very simple, but for the network engineer, that's what you need to remember. Now, what I have done here, I have provided this cheat sheet for you guys, and this is just scratching the surface. Okay, so I will be very honest here, because there is a lot more, and you need to come to VCIX to know. We can teach you, we can guide you, but this is how you can vaguely map the on-prem constructs to the cloud constructs. For example, the concept of pod in the on-prem is now converted in VPC in AWS. In Azure, it's called VNet. GCP calls it VPC. I mean, okay, that's fine. And then OCI took a different naming convention, VCN, Virtual Cloud Network, which is fine. So you don't have to worry about it, because when you look at the VCIX architecture, we are actually hiding all this. We are creating this abstraction, so you don't have to worry about all these details, different naming conventions, and how things are done differently in the background. Okay. All right. So that's what I wanted to discuss. And now let's talk about some other limitations, guys.
Yeah. So thanks, Shazad. All right, so there are lots of limitations, and we have already covered those limitations in previous tech talks. So this section, which we are going to cover right now, this is more focused towards the on-prem architects and on-prem engineers. So that would resonate well to you guys, because you guys are new to the cloud. And what is more resonating than the BGP limitations? So if I'm an on-prem engineer or architect, if somebody is bringing me a new toy, a shiny new router, and telling me, hey, by the way, this can do wonders, but you can only send me 100 BGP routes, what is going to happen? I'm going to say, what are you talking about? I don't want it, right? But this is the reality in the cloud. And you can see over here, wherever you go, that you cannot receive more than 100 BGP routes. On this picture, you can see everywhere, I'm highlighting static routes, a lot of static and manual intervention of the routing tables, which you have to do in the cloud networking field. In very few places, you are allowed to run the BGP. Now, let's talk about those limitations of the BGP. First one, I already talked about it. The second thing is, there is no concept of the route maps over here. So the blast radius is going to be huge. So whatever you are advertising, to your cloud environment, it's going to be propagated to all the spokes. So whether you advertise something or you don't advertise, right? This is the rule over there. So those controls not there. So if your partner wants to send, or by mistake or deliberately he's sending you a quad zero route, then he's attracting all the traffic from the cloud and bringing down your entire network. So those checks and balances are not available in the cloud. So at the same time, there is no traffic engineering capabilities. So if you wanted to prefer one path or the other for XYZ reasons, there is no such capability available, right? If you wanted to run the BGP except the private circuits anywhere else, doesn't matter whether it's the on-prem or within the cloud or with some other provider in the cloud, you have to rely on the tunneling protocol. And as soon as you introduce a tunneling protocol, that is going to bring down your throughput. And Shazad, again, is going to talk about that thing, right? So there is no concept of the route summarization and visibility. As an on-prem engineer and the architect, we know how important it is for us to know what routes am I receiving, what routes am I advertising. So this is really, really key.
Yes, exactly, Sad. You said it right. So this limitation, which I want to talk about, is something I couldn't believe, to be honest. When I first started working with the cloud constructs, uh, coming from the Cisco background, working in Cisco for 13 years, being a network and security engineer, that was something that was not I could even imagine in my dream, right? So basically, what is happening in the cloud, that when you are talking about encryption, right? Because encryption is extremely important. You need to build these tunnels using IPsec, right? Because when you look at AWS TGW, you're attaching the VPC. Those attachments are not encrypted. So you must use encryption. That should be part of your architecture when you're building it in the cloud. And when you build this tunnel, the IPsec tunnel, your throughput is only 1.25 GB, right? And I mean, this is like unbelievable. So why is it happening? Why is it only 1.25 GB? And when you peel the onion, you look at these the cloud providers or even third-party software routers or firewalls, you notice that when they're building the tunnels, they're not utilizing the full potential of those virtual machines. So the vCPUs are there, but only one vCPU is there to build the tunnel, and that's why. So Aviatix has this patented technology which can actually go beyond those limits. But yeah, as an engineer, that's something you need to remember. And that's the problem in the cloud. And when you're talking to the hybrid systems or the on-prem systems, you purchase 10 gig direct connect. You're paying expensive dollars for that circuit. That circuit is not encrypted. That's a big deal. And when it comes to encrypting that, when you run the IPsec tunnel over there, it's only 1.25 GB. So I think that was a big moment, aha moment for me, or a limitation in the cloud.
So now, today I think my job is all summarization. So let me summarize from another perspective, right? Okay. So what Saad and Shazad have talked about are, specifics, right? Connecting on-prem, connecting, branches and SD-WAN, IoT, encryption. These are important pieces. But I want to show you things from a different perspective as well. So if you think about cloud, let's say you take AWS, Azure, doesn't matter, VPC, VNets, all the same, right? Tomato. So if you look at a VPC as an example, what are the networking components inside a VPC? So a VPC has a subnet, a route table, a association, it has IGW, it has VGW, it has NAT gateway, and a bunch of other things, right? Now, if you really think about this, all of these components are working in a silo of their own. They're an island of their own. Route table has no idea what the NAT gateway is doing. A NAT gateway has no idea what the subnet is doing. And IGW has no idea what a VGW is doing. Like, all of these things are a silo of their own. So what that really means for you is that when one of these things break or misbehave or gets misconfigured or somebody makes a change, the other component is not gonna reflect or fix or adjust itself based on the other component's changed state. So what that means is that if any of these pieces break, then you have to go and figure out, needle in a haystack, which piece broke, why it broke, and then kind of find it. And if you only had 5 of these, maybe yeah, it was easier, but you have thousands of these. Now imagine you have, even 50, 100 VPCs and VNets and VCNs and couple of regions. Imagine the number of these networking components that you would have. And all of these components are, as I said, silo of their own. They're puzzle pieces, individual, independent. They have independent personality and responsibility, but they are not gonna work with each other. So what that means is that you have to build the logics to get them to work with each other. And imagine how, like, I hear people trying to use terraforms or cloud formation or this and that script to put these things together, which is great. Yes, of course you can kind of somehow put these things together in one steady state that you initially think you need. But as your environment changes and grows and adds and removes and DevOps building the environments and tearing it down, how are you gonna build and bring all of that logic into these different components and maintain and manage? And as the cloud providers release new features and capabilities, how are you gonna update your logics to benefit from that or protect from some of the changes that you don't want to adopt? And that's where a control plane based architecture comes into play. And that's why aviatrix is so important, so popular. And you have 500 plus enterprise customers using it, thousands of deployments, is because the aviatrix control plane takes all of these native components and gets them to work with each other. Because now this control plane is looking at what a route table, how a route table is configured, a IGW is configured, a NAT is configured, what association is are configured, which route table is associated with which subnet, which VPC is connected to which transit, and all of that, right? So now if you have a route that just got withdrawn and a new route came in, or a new VPC was created, or a new subnet was created, the control plane is making sure that there is an end-to-end consistent networking for your data plane and your enterprise applications. And that piece is not just limited to the native components, it includes the aviatrix components of the gateways, and it extends to networking and security provided by third parties, as an example, Palo Alto, Checkpoint, Fortinet, F5, and for operational visibility, Datadog, Splunk, Okta, Duo, like all of these things talk to the aviatrix control plane, because aviatrix control plane is a multilingual control plane that can talk to all of these things. And if you think of about, now that I've kind of presented the control plane based architecture to you, and if you look back at the native architecture or native components, it's like, you go to a dealership, you go to Tesla saying, hey, I love your car, I saw the ad, it's amazing, I want it. And Tesla gives you the 50,000 parts that it used to build a car, saying, here's the manual, go build it yourself. So literally, that's what the thing is. And I would love if any of you want to share your thoughts, reach out to us on LinkedIn, or ping us however you want. We're out there available to chat. But that's literally what we are seeing, and it's surprising for enterprises to go other route. And just the last thing I would say, I was just doing quick maths in my head, right? And the few hundred people said aviatrix, right? Just in the last 1 year, within average of, let's say, 50 hours a week. Well, it's actually more than 50 hours, but well, it's about, let's say, 50 hours a week for like 50 weeks in year. Just in the last year, we've spent more than 500,000 hours in public cloud networking and security, in improving and building and solving challenges using this control plane architecture. So I think this is a very, very unique challenge in the cloud that we are solving, but this is really a platform for the network engineers, because without this, it's going to be tough.
Yep.
Yeah, so Hamad, myself, Shazad, we all actually talked about some of the challenges, some of the limitations of the native constructs. So what is a solution? So solution basically lies under the architecture, a architecture, which is the multi-cloud network architecture, right? That is provided by the Aviatrix. So the challenges of the overlapping IPs, the challenges of the throughput that Shazad talked about, the challenges of the no control plane in the cloud, the challenges of the BGP routes, like if you want to send thousands of routes, you can send it to the Aviatrix. Aviatrix has no problem. Then the challenges of the managing the routing table, insertion of the FireNet, all those kind of different challenges, these are all covered under the multi-cloud network architecture. So this is the Aviatrix MCNA. And now we want to talk about some of our personal experiences, since we all came from the on-prem world. So if I wanted to provide my personal experience, I came from the Cisco as a Cisco ACI solutions architect, and then VMware NSX and the Velo Cloud architect. Then I have a different frame of mind. I'm like, okay, if I'm going to architect something, then there has to be some architecture available to me, right? And based on that, for example, in on-prem world, there is a class architecture, like your spine and leaf, your three-tier architecture, the access, aggregation, and core. So basically, the architectures are well defined over there. So nobody is going to make a mistake of inserting a 2950 switch in a core layer. If they are going to do something like that, what are they doing? They are actually going to melt down the entire network. So if I'm going to ask the same question to the cloud architect, the main focus for the cloud architect is to just make my application available to the on-prem internal users and available to my consumers, like my customers, basically. For that, they are going to utilize any available the services provided by their CSP without thinking about how these services are going to play out in the long run. So most of the time, they end up doing a massive redesign of their entire cloud because they didn't have any architecture. So what Aviatrix provided the architecture that I discussed previously in the previous slide, which is called the MCNA. So that was the biggest, experience for me. So Shazad and Hamad, if you guys want to share yours.
Yeah, absolutely. So, I'm not as deep networking as Saad or Sharad. I'm like more of a trail mix, right? Which has all kind of bits and pieces from here and there. I started with Microsoft supporting networking pieces, if any of you remember RAS and ISA server, ISA server, and that kind of stuff, and then Riverbed, VMware doing a lot of NSX and Kubernetes, VCDX, and all that kind of certification. And when I came to Aviatrix, I had very little, cloud experience, and I wanted to, of course, being at Aviatrix, wanted to transition into cloud-focused SME. And that's about like what, Shazad, about 2 years ago, right now, like it's coming up to in few months. So
Yep.
we kind of now started to around the same time, and we were like, okay, we need to start learning cloud, right? So we started AWS Solutions Architect certificate, which is, I mean, great, but it has the, I mean, at the end of the day, I felt like they just wanted me to know the 50,000 services that are there and the purpose of those services. I mean, no offense. I mean, that's good, but as a network engineer, it didn't resonate with me, to be honest, right? Okay, 10% of that was probably about VPC and stuff, and then we were like, okay, maybe we take the AWS networking specialty, right? Which was good, but it was very focused to the way AWS wants to do things. It was not, and it was not built for networking, right? I mean, It's a great course, and actually one of the course creator, James Devine, he's actually part of our team now at VCIX. So I'm not saying that the course was bad, but it was not really networking for network engineers. It was just networking and how you can get the AWS pieces to kind of talk to each other, work with each other. Then we went to try. It was like, okay, let's do the Azure piece, and actually we had a very tough experience with Azure networking, because Azure certification tracks have zero, like maybe 5% or less networking focus. We actually went and tried to get training from external providers, and we requested networking focus, but we didn't really get much, right? And then at the end we realized that we just need to learn it ourselves, and then we were together, between Sasha, Azad, myself, and our teammates, and you probably guys have heard others on these tech talks, and Brian, Manny, and others. We kind of worked together, and we built our expertise and working across all the clouds, GCP, OCI, and the stuff. But at the end of the day, what we realized together is that for a network engineer, there is no cloud focused track, right? And then we were like, you know what, this is something that we gotta fix.
Yeah, yeah. There is one now, Hamad. So that's gonna be for my next slide. So yeah, like you said, Saad, if you can move on to the next one. So I came from Cisco, right? I'm at double CCI, VCDX, was on the VCDX panel. I'm an NSX book author as well. So I thought that, okay, I know networking very well. I can just, start learning cloud. And like you said, I started with a certification journey because that's how I wanted to, start learning things. And like you said, the course, the AWS course that you mentioned, it's good, but that's not the introductory level course. This is for someone who has already done like number of years of work with AWS networking. So myself, Hamad, Saad, and a couple others, we sat together. We said, dude, we need to fix this problem. So that's where we created this VCIX certified engineer track for people like you, right? Who are coming from on-prem, who are new into the cloud networking. It's a great opportunity for you to take that course. It starts from associate, goes to professional, and then to design architect. Now we have cloud ops as well. So definitely something you need to consider if you are about to learn cloud, or if you're already in the cloud and you're clueless. So that's will give you, good start. Then we have something what you see called sandbox starter. Okay, so again, if you're learning something, if you're like me, I would like to do things hands-on, and I wanted a jump start, right? So this is exactly why we created this sandbox starter, which is available on our aviatix.com website as well, all the details and everything. Basically what it does, it gives you a simplified UI, which, and you need to provide maybe 4 or 5 pieces of information. You click next, and then it's gonna build this cloud network in AWS, in Azure, if you want. And that's like, super duper. I have received numerous emails and kudos, like, you made my life easier, because what it does, it hides all the complexity, all the abstraction, and gives you this simplified view into the cloud world. So yeah, so this is what I wanted to, highlight here, my experience working with this cloud. And if you guys want to reach out to us, we have our email there. Our documentation is extremely simple and comprehensive. Take a look. And if you want to talk to us in a personalized session, one-on-one session, definitely reach out to us and we'll definitely help you.